Stared at a dead, completely unresponsive gadget, maybe your favorite TV or a really expensive laptop charger, and just felt that sinking feeling that it's gone for good? Well, welcome to today's Explainer, where we're basically putting on our lab coats and stepping into the clinic. We're going to explore how everyday people are diagnosing the dead and literally bringing printed circuit boards back to life. So think of me as your electronics doctor today. We're going to uncover the hidden logic right inside that plastic casing.
Okay, here's our roadmap. We'll kick things off with the art of repair. Check out essential diagnostic tools and key electronic components, then dive into understanding power supplies, step-by-step troubleshooting, and wrap up with the massive DIY repair movement. Section 1, the art of repair. You know, popping open a device can feel totally overwhelming, but fixing electronics is actually a very logical process. The big question we're tackling is how on earth do you find a tiny, almost invisible fault on a massive, complex circuit board? It helps to think of the board like a patient waiting for a diagnosis, but the symptoms might be completely hidden from the naked eye. I mean, a blown microcomponent doesn't always go up in a puff of smoke, right? Sometimes it just quietly fails. And hey, if that sounds intimidating, you are definitely not alone. Get this, over 1.2 million people have tuned in to a single guide created by Technomitra, which is literally titled, Learn to Find Circuit Board Faults Step by Step. That staggering number proves there is an entire army of DIYers eagerly learning this exact diagnostic art. Moving on to Section 2, Essential Diagnostic Tools. So, you really can't diagnose what you can't measure. And the multimeter, that is your electronic stethoscope. Without it, you are completely blind to what's happening inside the board. It measures voltage, current, and resistance, meaning you can literally listen to the electrical heartbeat of the components. It lets you see exactly where the power hits a dead end. Let's look at the actual vital signs you'll be checking. You've got amperes for the flow of current, volts for the pressure, watts for overall power, and continuity, which basically tells you if a circuit path is unbroken. Source tutorials covering just these basics are pulling in massive audiences, up to 900,000 views, because mastering these measurements is like checking a patient's pulse. It's the absolute bedrock of finding any fault. Section 3, Key Electronic Components. Every single little block and cylinder on that board has a very specific job. Diodes, for example, act like one-way valves for directional current flow. You test them to make sure nothing is leaking backward. Then you have transistors and MOSFETs doing the heavy lifting of switching and amplifying signals, and of course, SMD LEDs, which require specific watt and volt verifications to ensure light emission. Learning these is literally like learning the internal organs of the machine. Now, understanding specialized components like the MOSFET is super vital. MOSFET stands for Metal Oxide Semiconductor Field Effect Transistor. It's a mouthful, I know, but it's a crucial switching component, especially in AC boards, and it takes a massive beating. It frequently fails under extreme electrical or thermal stress. Sometimes it even releases that dreaded magic blue smoke of a fried circuit. When a device dies entirely, this component is very often your prime suspect. Okay, Section 4, Understanding Power Supplies. A lot of device skilling faults originate right here in the power supply. The SMPS, or switched mode power supply, uses a switching regulator to convert electrical power incredibly efficiently. Basically, it takes the raw, dangerous power from your wall outlet and translates it into the safe, low voltage power those delicate microchips need to survive. If the SMPS fails, the whole system just starves. A healthy SMPS just hums along, consistently regulating voltage and keeping the brain of the device powered without overheating. But a faulty SMPS, absolute havoc. It can cause a full dead state where nothing turns on, or it creates incredibly frustrating secondary symptoms like a weak signal or fluctuating power outputs. Often, people assume the main microchip is broken, when really it's just starving because the power supply failed. Section 5, Step-by-step troubleshooting. Alright, let's translate all this theory into a hands-on rescue mission. Step 1 is the visual check. Just use your eyes to look for burnt spots, bulging capacitors, or cracked joints. Step 2 is the component test. Grab that electronic stethoscope we talked about and probe for values. Step 3 is fault isolation, narrowing the problem down from the whole board to one single bad component. And Step 4 is SMD soldering, removing the bad organ, soldering in a fresh one, and waking the patient back up. So what does a successful fault discovery actually sound like? Well, a healthy component like a working diode acts kind of like a security gate. It only allows current to flow in one specific direction. But a shorted, blown diode is a broken gate. It allows current to just freely flow both ways. When you test this broken component with your multimeter on the continuity setting, it's going to trigger a loud, continuous beep. that beep? That is the ultimate aha moment in electronics repair.
And finally, Section 6, the DIY repair movement.
Stepping back from the technical schematics for a second, the sheer scale of social proof around this stuff is immense. Look at these view counts on DIY repair tutorials. 4.1 million views just to learn SMD soldering. 2.8 million for component testing. Millions of people around the world aren't just chucking their broken electronics in the trash and contributing to e-waste. They are actively seeking out the knowledge to crack them open and fix them with their own hands. And this perfectly reflects a core philosophy from Technomitra. Learn to find circuit board faults step by step. You see, this isn't just about saving a few bucks. It is a really empowering psychological shift. It represents the transition from being a passive consumer who's just helpless when a screen goes black to an active, capable fixer who actually understands their own technology.
So, I'm going to leave you with this thought. The next time an electronic device dies in your home, will you blindly throw it in the trash? Or will you grab a multimeter, pull up a schematic, and become the doctor? The symptoms are there to be read, the tools are totally accessible, and millions of people are already doing it. The power is literally in your hands. Thanks for joining me for this explainer today, and keep exploring.